So let's look at a couple simple examples for combining resistors. So for starters, let's say we have this setup where we've got three resistors. We've got R1 up here, we've got R2 and R3 down here. We're told what their resistance values are. So R1 has a resistance of 100 ohms, R2 is 200 ohms, R3 is 300 ohms. And so what we want to do is we want to calculate what the equivalent resistance is for this set of three resistors. So the first thing we have to do is we have to recognize, well, which two should we combine first? And so what we see here is at this junction, right, the current comes into this junction and splits. Some of it goes across R2, some of it goes across R3. It recombines at this junction and goes out. So clearly R2 and R3 are connected in parallel. And so that's where we're going to start. I know that if I have two resistors that are connected in parallel, that means that the voltage across them has to be the same. So that tells me that the voltage across resistor 2 has to equal the voltage across resistor 3, and that's also going to equal the voltage across the combined element 2, 3 when I put them together here in a second as an equivalent resistor. I also know what my rule is for calculating the equivalent resistance for resistors connected in parallel. So here I'm going to use 1 over R23 equals 1 over R2 plus 1 over R3. Now to minimize my mistakes, again, I'm going to go ahead and choose to solve this using that R23 equals R2 times R3 over R2 plus R3. So this is going to be 200 ohms times 300 ohms divided by 200 ohms plus 300 ohms. And my calculator tells me that happens to be 120 ohms. Effectively what I've done here is I've said I'm going to replace these two elements individually labeled R2 and R3 with a single combined element called R23. And that single element R23 has a resistance of 120 ohms. So pulling out 2 and 3 individually, replacing them with this single resistor that I've labeled R23 doesn't change anything about the way the current is flowing through the rest of the circuit. Well, now I have two resistors. So I have my original resistor R1 and now my combined resistor R23. And what I notice, of course, is that they are connected in series. So all the current that comes across R1 has to come across R23. There's no junction, no place for it to split. So these two resistors are connected in series. Again, what does that tell me? Well, the first thing it tells me is that the current flowing through them has to be the same. So the current that flows through R1 has to be the same as the current that flows across my combined resistor R23. And then that's going to be the same current that flows through the combined element when I put the two of them together, which I'll label 1, 2, 3. The other thing I know is I know my rule for combining these resistors. So if I have two resistors connected in series, then their equivalent resistance is simply the sum of the individual resistors. So when I add this together, I get that the equivalent resistance for all three, so now R1, 2, 3, is going to be the resistance of R1, 100 ohms, plus the resistance of my combined element R2, 3, that was 120 ohms, 100 plus 120 plus 120 is 220 ohms. So this means that what I've done is I've boiled my circuit down. So my three resistors that I started with, I've combined them into a single equivalent resistor, R1, 2, 3, that has a resistance of 220 ohms. Let's look at a second example. So again, three resistors, same values, R1, R2, and R3. All I've done is rearrange how they're connected. And again, here what I notice is, well, if I come into the junction and think about how things are split, well, if I come in, I go across R2, come back to this junction on the other side. But if I go the other way, go into the junction, come out, go across R1, I have to also cross R3 before getting back to the junction where that current's going to recombine. So what this tells me is that R1 and R3, those two resistors are connected in series first. So before I worry about what's going on at the junction and where the current's splitting, I've got to combine R1 and R3 in series initially. Well, I know that if I have two resistors that are connected in series, that means that the current flowing across each of them has to be the same. So the current flowing across resistor 1, there's nowhere else for it to go except for across resistor 3. So those two have to have the same amount of current, and that'll be the same current that flows through the combined resistor 1, 3 when I put them together here in a second. I also know my rule for combining resistors connected in series. Again, their equivalent resistance is just the sum of the individual resistances. So in this case, I know that the combined element R13 is going to have a resistance that equals R1 plus R3. That's 100 plus 300, that's 400 ohms. So I have taken R1 and R3 and combined them into a single element, R13, that has a resistance of 400 ohms. Well, now I can see that when the current comes into this junction, some of it will go across R2, the rest of it will go across R13, and then all that current will recombine at this other junction. So this tells me that R2 and R13 are connected in parallel. If I have two resistors connected in parallel, I know that their voltage must be the same. So the voltage drop across R2 is going to be the same as the voltage drop across the combined resistor R13, and that's going to be the same as the voltage drop across when I put them all together into a resistor that I'll label R123. I also know my rule for calculating the equivalent resistance of two resistors connected in parallel. So here 1 over R123 has got to be 1 over R2 plus 1 over R3. Again, I'll go ahead and use my rearranged equation to minimize my mistakes. So I get that R123, the equivalent resistance putting all three of these resistors together, is going to be equal to R2 times R13 over R2 plus R13. That's 200 times 400 over 200 plus 400. That's 133 ohms. So when I have combined my second set of three resistors here, what I end up with is a single equivalent resistor, R123 again, but now it has a resistance of 133 ohms simply because of the way that I connected them in this case. It was different than the way I'd connected them in the first.